Hello everyone. In this video, we will understand the basics about the differential equations, and we will understand what do you mean by solution of the differential equations and why do we need numerical methods, okay, for solving the ordinary differential equation when we have already studied the solution of the differential equation in our +1 and +2 classes. Okay, so what is like numerical methods all about? Okay, so this video will be like preparation for understanding the numerical method that we will be seeing in our upcoming videos. Okay, so we will be understanding the whatever is needed to understand the numerical methods. Okay, we will not understand like very much mathematical related things, okay, about the differential equation, but whatever is needed we will understand. Okay, so let's start. So let's first understand what you mean by derivative. Okay, so in your +1 +2 classes you must have understood like we can write d of y upon d of x. So you say that this x is an independent variable and y is dependent variable. That means y changes as x changes. Okay, so basically to this notation, okay, dy upon dx. Okay, so basically this notation dy upon dx, this is called a derivative. This is a derivative. Derivative means rate of change of this y, okay, with respect to x. When x changes, how y is changing. To express this thing, we are using this notation, okay, this derivative basically. Okay, so for example, from A to B, you take t time, okay, to travel the distance, let's say x. Okay, x distance is traveled in t time. Okay, now you want to find like how much time it will take to travel the distance from A to C. Okay, then you will need the concept of derivatives. So for example, you are given this question that a plane can move the distance of 50 kilometer in 2 hours. Okay, it can fly 50 kilometer in 2 hours. Now we have to find the velocity. Okay, so velocity, as you know, velocity means the rate of change of the distance with respect to time, right? So what is the formula for the velocity? So velocity in simple terms, you can say that it is like speed. So speed is equal to, or you can say velocity. Okay, so velocity is equal to distance upon time. Okay, so here we will use displacement. Okay, so displacement, let's say x upon time, right? So here displacement is 50 kilometer and time is 2 hours. So 50 by 2 is 25 kilometer per hour. So basically this velocity, okay, this velocity is telling you that in per unit time what is the distance traveled, right? So this velocity is basically the derivative. You can write this velocity as, you can say, dx upon dt. Okay, in actual mathematics term, that with respect to time, how this distance traveled is being changed. Okay, with the change in time, how this x distance traveled is being changed. So here it is the significance of the derivatives. Okay, so for example, in real life you say okay, with the time how the oxygen level is changing to d of oxygen level upon d of time. Same way how the temperature is increasing or let's say changing with respect to carbon dioxide change. So this carbon dioxide level increases or decreases. Same way, based on that, this temperature, that is this dependent variable, this temperature is dependent variable, this can also change. So to express all these terms, okay, all these lines, we use this notation. This is called derivatives. Okay, derivative can also give you some other information. For example, this is a function y equal to fx, mathematical functions. Okay, and let's say we find the derivative dy upon dx. Okay, derivative of this, then this will tell me the slope. Okay, this slope. Now what do you mean by slope? Slope means this is the curve or this function. Now if I draw a tangent, okay, a straight line touching at this point, so this is a tangent. So basically dy upon dx will tell me the slope of this tangent. Okay, and if you want to know the derivative of this function, and if you want to know the slope at particular x1 comma y1, you can put the values of x1 comma y1 accordingly. Okay, and this derivative, as we have discussed, that it can tell you the instantaneous rate of change at a point on the function. Okay, so we saw the velocity. Velocity is also the like change. Okay, change of x with respect to time. Okay, so now let's move forward. Now we can have many type of derivative. For example, we can have first order derivative, second order, third order, fourth order, and so on. For example, you are given this function y equal to this. Okay, so this 3x square plus 5x plus 2, it is a function, right? Now, if you find the derivative, okay, you differentiate it. So dy upon dx, right? Rate of change of y with respect to x equal to, like, you know the differentiation, so I'm not telling you how to do differentiation, right? So this is like 6x plus 5. Okay, now we can also express this dy upon dx as y dash, okay, equal to 6x plus 5, or we can express this as like f of f dash x equal to 6x plus 5. Okay, so these all are equivalent. Okay, this all these are same things. Okay, now this dy upon dx or y dash or f dash of x. Now, if we differentiate this dy upon dx again, okay, then we will get d of d squared y upon dx square equal to 6. Okay, if we differentiate it again. Now, we can write this derivative as y double dash or f double dash x. Okay, again, these are all same. So, this is first order derivative, this is second order derivative. And if we differentiate it again, okay, d of 3 upon dx of q, and for constant differentiation is 0, then this is third order derivative. Okay, so these are like different like order of derivatives. Now these derivatives are also called as ordinary derivatives. Why ordinary derivative? Basically ordinary derivatives means that your function, your let's say y, it is changing or it is dependent on only one quantity, on only one variable. Okay, so y is dependent only on x, right? Okay, you will understand it more when I will tell you what are partial derivatives. So what are partial derivatives? Suppose we have this function f x comma y. So this function is dependent on x and y. Okay, so basically there are more than one variable on which this function is being dependent. Okay, 3x square plus 2x plus 4x y square. Okay, two variables. Now, if I want to differentiate this function, okay, then whatever derivatives I will get, those derivatives will be called as partial derivatives. Actually, these are called partial derivatives. Okay, I differentiate this function f, okay, with respect to x. I differentiate this function with respect to y. Okay, now here when I differentiating this function with respect to x, okay, then I am assuming that y, that is the another variable, is constant. Okay, and here I am differentiating with respect to y, then here x is kept as constant, then only I can differentiate this function with respect to y. Okay, so these all are partial derivatives. Again, there can be a function f x comma y. It dependent on 3 x, y and z, 3 variables. Then I have to find the another partial derivative also, del of f of del of z. So this is another partial derivative. Okay, so basically partial derivatives of functions, these partial derivatives are dependent on, you know, more than one variable x, y, z. Okay, in the previous slide we saw that our function was dependent only on one variable. Okay, then whatever derivatives we will find, those will be called as ordinary derivatives. Okay, so now I think you have understood what is ordinary derivative, what is partial derivatives. Okay, and the process of finding these derivatives, these partial derivatives, is known as partial differentiation. Okay, I think you have now recall whatever you have understood in your +1 and +2 classes. Okay, so now let's move forward and see what is differential equation. So differential equation is an equation which consists of one or more derivatives. Okay, one or more derivatives and one or more terms. So let's understand with the help of example. Okay, so here you can see we have y dash equal to 2x. So this y dash can be written as dy upon dx also. Okay, equal to 2x. Okay, so this is derivative and this is like simple term. Okay, so the relation, or you can say our equation which shows the relation between derivative and some simple terms, those relation is called as a differential equation. Okay, so the differential equation is basically a relation between derivative and the simple terms. Okay, now here also we have like this is first order derivative, right? Because now in the second example we have this y dash plus y double dash equal to this. Okay, so basically this is also a differential equation. Again, y dash equal to 2 of this trigonometric function sin x. Okay, this is differential equation, this is differential equation, and here you can see this is del of u upon del x plus del u upon del y equal to 5. Now I forget to tell you that whenever whenever we are finding the partial differentiation, okay, or you can say partial derivatives, then this we will not write like d of x upon dy. We will simply tilde it, the del of x upon del y. Okay, so this is like to show the difference between the normal derivative and the partial derivatives. Okay, so this is also a differential equation. Now all these first four equations, these are like ordinary differential equations, okay, because these all involve the ordinary derivatives. But here in this fifth example, these are like partial derivatives. So this equation which involves the partial derivatives, it is known as partial differential equation. Okay, but all are differential equations. Now when we talk about differential equation, we also talk about the order and the degree of the differential equation. So let's understand with the help of example what is order and degree of differential equation. So for example, this dy upon dx equal to 2x is there. Okay, so here this is the highest order derivative in this equation, right? In this equation. So when we are finding the order and the power, we will talk about like we will see the derivative only. Okay, so dy upon dx is only the single derivative in this whole equation. Now here you can see it will be like 1, it will be like first order derivative, it is like as we have seen in our previous video. So you can see there will be a hidden 1 here. Okay, so you can simply say that this is the order, this is the only single derivative here, and in this is the order. Okay, so this will be the order of the differential equation. And degree means whatever the highest order derivative present in the equation, what is the power here. So here it will be like 1, so degree is also 1. Let's say we have this y dash plus y double dash equal to this. Okay, now this equation can be written as like this. This is first order derivative dy upon dx plus this is double. Okay, or you can say second order derivative d square y upon dx square. Okay, and this equal to 2x square plus 3x. Now here in this equation, if you want to find the order, so what is the highest order derivative? First let's see that. So highest order derivative is this second order. Okay, d square y upon dx square. So check only this. Okay, and now check here what is this order or what is the value here. So here it is 2. Okay, so this is the order of the whole differential equation. Okay, now to find the degree, check again the highest order derivative. This is the highest order derivative, this is first order, this is second order. Now outside this, okay, outside this in the power, what is the value? It will be 1 only. Okay, so that is the degree, right? Okay, now here this is like first order derivative. Okay, so dy upon dx, for this order you can say first order derivative, so again the same way it will be 1. Now del u upon del x, again this is simple partial order derivative, but the concept will remain same. Okay, here it is like both are first order derivative only. Okay, so basically here it will be like 1. Okay, it will be 1. Okay, so both are like first order derivative, so order and degree will be both, because outside also it is like 1. Okay, now for this is important. Okay, so let's see here. Now here you can see in this equation, if you want to find the order, so we have to concentrate on the highest order derivative. So this is the second order derivative, this is the first order. Okay, for order we have to see here. So this is 2, so this is order. Now to find the degree, check the highest order derivative, this is this. Now outside this 4 is written, so this is degree 4. Okay, degree 4 of the whole equation. Now this is again important. Now 10 dy upon dx equal to x plus y. So here degree is the order of the highest order derivative, that is you have to see here. So what is the order? Simply 1. But degree is not defined for this equation. Why? Because this is not a polynomial equation. For polynomial equation only the degree can be defined. Okay, so sometimes it happens like we are given the equation, but it involves the trigonometric functions. Okay, but sometimes you have to like change that equation so that you can find the degree. But sometimes it will be like you will not be able to convert that equation in any form so that you can find the degree. Okay, so whenever like you find the derivative and some trigonometric function like the tan of something, okay, so then you can simply say degree is not defined. Okay, so for these type of things, degree is not defined. So degree will it is not like that it is defined for every equation. For some of the equations, degree will not be defined. Okay, so this was just the recap. Okay, more you can see online. Now we can have different type of differential equations, like first order differential equations. Okay, for example, this is first order differential equation, second order differential equation like this. Okay, and we can have linear differential equation, homogeneous differential equation, and so on. But we will not be covering those things here. Okay, now let's move forward. Now, what is the significance of differential equation in our mathematics or physics or somewhere else? Okay, so for example, I will show you with this example. Let's say you want to study the how the population of the, let's say, cats is increasing with time. Okay, and let's say you are given that the rate of growth of the cats is this, like 0.01 for every current cat in a week. Okay, so let's say in a week, okay, let's say you have some cats. Okay, let's say x number of cats, and rate of growth of the cat is like 0.01 for every cat in particular week. And you have to tell, like, if this is the growth, okay, if this is the, like, rate of growth of the cats, it is given, and let's say you have certain number of cats. Let's say here in this example you are given that there are 1,000 cats. Okay, so you have to tell in a week how many number of cats will be, like, will be new. Okay, how many new cats will come. Okay, if rate of growth of the cat is this, so you will say, okay, population is this, so rate of change will be like 1,000 into 0.01, that is, you can say the 10 new cats will come in the every week. Okay, if rate of change is like this. Okay, and if the population is this 2,000, okay, current number of cat is 2,000, then with this rate of change 20 new cats will come in every week. Okay, so basically when you will be understanding this, or when you will be formulating these type of problems, then you will be formulating these type of problems in differential equations. And here you can see something is changing, right? Population of cat is changing with respect to time, so you can say d of, okay, population of the cat with respect to day of time. Okay, and that's simply like there will be some more terms, so a differential equation will be found, and then you have to solve that equation so that you can find your answer. Okay, so there differential equation comes to picture, and we can make the use of the differential equation. Same way we can have another use cases of the differential equation that we have maybe you have seen in your physics, okay, or in mathematics. Okay, like these are some of the use cases. Okay, now let's see what we mean by solution of the differential equation. So basically, solution of differential equation means we want to find the function corresponding to the given differential equation. Okay, so let's see with the help of example. Okay, for example, if you are given a algebraic equation, for example, this x square plus dx plus 2 equal to 0. Now we have seen in our classes that we can use the concept of middle term splitting. Okay, and then we can find the solution. So the value of x will be -2 and -3, right? This is the algebraic equation. Now if we are given a differential equation, for example, y dash equal to 2x, or you can say dy upon dx equal to 2x. This is the differential equation. And somebody says you have to find the solution of this differential equation. So what do you mean by this? So it means you have to find a function y, okay, y something, which can satisfy this differential equation. If something you are able to, like, find that y equal to something, you are able to find that function which can satisfy this equation, then that thing will be called as solution of this given differential equation. Okay, so for example, if you are given this differential equation, okay, and somebody comes to you and he say y equal to x square, this is the solution of this differential equation, then how you will verify whether this is the solution of this differential equation? Okay, we are not directly finding the solution, but somebody gave you directly that this is the solution. So how you will verify whether this y equal to x square is the solution of this differential equation? So it is very simple. What do? You want what? This dy upon dx, that is derivative. So if you find the first order derivative of y, what you will get? Dy upon dx, okay, equal to 2x, right? So if you differentiate this, you will get same this thing, right? You will get the same thing. That means this solution is actual solution of this differential equation. Okay, so this function is the solution of this differential equation. Now there can be another solution also for this differential equation. there is like a function y equal to x square, let's say 4. This is also one solution for this differential equation. So this was first solution, this is second solution. And how you can verify? Again, you differentiate this. So it will be dy upon dx equal to 2x, and for 4 the constant differentiation is 0. So again you got same thing, same differential equation. So that means this is also another solution. So in this way, if you see that for constant the differentiation is always 0, right? So if I say y equal to x square plus 10, y equal to x square minus 50, all these are solutions of the differential of this given differential equation, because for constant the differentiation is always 0, so you will get always 0 here. Okay, always 0. Okay, now in general you can say y equal to x square plus any constant. This function, this equation will be the solution of this differential equation. Okay, so this is called a general solution of this differential equation. Now you also understand that for a given differential equation it can happen that there is only one solution, or there can be many solutions, or you can say there can be class of functions which can satisfy, or which can be like candidate, or which can be solution for this given differential equation. So here we can see there can be many solution of this differential equation, and this is the general solution. Okay, so graphically you can see these are the different solutions, okay, that are possible for this. Okay, you can put c as anything. Okay, like for example c as 0. Okay, if c is 0, that means this y equal to x square, here c is 0, y equal to x square. Okay, this is the equation. Okay, this parabola. Okay, this is also the solution. Or you can say this y equal to x square plus 10, x square minus 50. Okay, these are the constant values. Okay, so these all different functions can be the solutions. Okay, now let's say we have this differential equation. Okay, and we have second order derivative plus 2 of y of dash equal to 3y. Okay, now we have to find the solution of this differential equation. So we'll see that we will have like more than one solution for this differential equation. Okay, so let's say somebody gave you y equal to ex. Okay, this is one solution of this differential equation. How? Okay, let's see. So here we want to just verify that whether this is the like solution for this differential equation or not. Okay, so if here you can see we have to find the first order derivative, second order derivative. Okay, then after finding those derivative we will put in this equation. Okay, and then we'll see whether this left hand side is equal to right hand side or not. If yes, then we'll say this is the correct solution for this equation, otherwise not. Okay, so let's find the y dash, that is first order derivative. Now you know for ex the differentiation remains same, e of x. Okay, now second order derivative will be again for ex differentiation is ex only. Okay, now you put this in here. So ex plus 2 of ex equal to 3 of. Now what is the value of y? Value of y is ex. So you got 3 of ex equal to 3 of ex. That is left hand side is equal to right hand side. That means this is the solution of this differential equation. There can be another solution. For example, y equal to e minus 3x. How? So again verify y double dash equal to, now differentiation will be minus 3 this one. Okay, sorry, this is the first order. Second order derivative will be like 3 3 are 9 positive e of 3x. Now you put these values here. Okay, in this equation. Okay, so it will be 9 e of minus 3x. Okay, plus 2 into this. Okay, so it will be 2 multiply minus 3 of this. Okay, it will be minus 6 e 3x. Okay, equal to this 3, y is e minus 3x. So 9 minus 6, it will be like 3 e of minus 3x. So this is equal to this, left hand side equal to right hand side. This is another solution. Okay, so this way you can verify. Now we saw in the previous video that when we have this differential equation y dash equal to 2x, this was the general solution. Okay, now there is another type of solution, it's called particular solution of the differential equation. Particular solution means this is the general solution. Now we are given some point, okay, some value, okay, x comma y. Okay, and now we have to find the solution of this differential equation, one particular solution. Okay, or you can say we have to find a function which is basically passing via 2 comma 7. That function only, that particular function we want. Okay, which is the solution of this differential equation. Okay, so this type of solution will be called as particular solution. For example, this is the solution that we saw as a general solution. Okay, now if we put these points 2 comma 7 also, okay, so this is x and this is y. So 7 equal to, after finding the general solution, we are putting these values, x square, that is 4, okay, 2 ka square 4 plus c. Okay, so c will be 7 minus 4, 3. Okay, so now after putting the point, we got c equal to 3. So if I put in this equation y equal to x square plus 3. So this is the particular solution which is passing via 2 comma 7. That is, this is the function. Okay, you can write f of x equal to x square plus 3. Okay, so this line x square plus 3 will be passing via 2 comma 7. So if you see here, this is basically c value. Okay, c. Okay, so basically 2 comma 7 will be 2. Okay, and 7 will be like this here. Okay, here. So when this c is basically 3, 0, 2. Okay, and 3 will be like here. So basically it will be this type of line. Okay, and this will be like 2 comma 7. So this is the particular solution which is passing via 2 comma 7. Now here we have just saying like, okay, if we are given a solution and we can verify. Okay, now in normal mathematics, what we do is, if we have to find the solution for this, let's say, given differential equation, how we can find or how we can reach to this function. So basically this is differentiation. If we integrate, if we apply integration on these, okay, on this function, okay, then we will get this thing. So it will be like integration of y dash equal to integration of 2x. So integration of y dash will be like y, and then this 2 will be outside, and this is like xn. Okay, xn plus 1 and plus 1. I know you know the integration, so it will be like x and then 1 plus 1, 2 by 2. Okay, this is out. So y equal to x square. Okay, and then when we do the integration in this way, we add the constant also. Okay, I hope you recall. Okay, so this y equal to x square plus c. So in this way, actually, basically with the help of integration or the another methods, we can reach to the this solution. Okay. Now sometimes the question is given in the form of initial value problems. Initial value problem is same thing, like we have the differential equation, and you are given some initial value like y, the function value at x equal to 0. Okay, y of 0 equal to 5. So this is basically value of y. Okay, and this is basically value of x. So at this point, okay, you have to find the solution. So basically this is again a particular solution. You have to find the particular solution at this value of x comma y. Okay, so again you will find the integration. You will do the integration, and this is the whole integration. And after the integration, okay, you will put these values x and y. Okay, and then you will find the constant, and you will put the constant here. Okay, so in place of this c, you will get 2. So in this way also, okay, so basically in this way also you will be given the question. This is called as initial value problem. Okay, you will be given the initial values, differential equation, and you have to find the solution at this initial values. Okay, so now let's see, why do we need numerical methods? So to find the solution of differential equations, we can have many methods. Okay, like we saw this integration methods. So there can be other methods also. So those are called as analytical methods. Okay, there are some equations which cannot be solved by these analytical methods. So to find the solution of those equations, differential equations, we need numerical methods. Okay, and numerical methods will not give me some equation. They will give me some values. Okay, in like some numerical values. Okay, so this is the one important difference between the numerical method, analytical methods. Okay, as we saw, we got some answer in the form of y equal to something x square plus 1 something. Okay, a function basically as the solution. But in numerical method, we will get some values, finally some concrete values. Okay, x and y, some concrete values. For example, okay, for example, you will be given like this is a differential equation, and there are some initial conditions given, y0 equal to 1, and then we have to find the solve the equation at x equal to 0.4, something like that. Okay, so we will get some numerical value when we will solve this equation, find the solution of this differential equation with the help of numerical methods. Okay, so these are the various numerical methods which can find the solution of differential equation: Picard-Taylor, Taylor, and Runge-Kutta methods. Okay, Milnes methods. Okay, so we'll see some of these numerical methods in our upcoming videos. Okay, So this was all about the differential equations. In the coming video, I'll tell you some of these examples or some of these numerical methods with the help of C programs. Okay, so do watch that video. So please do like, share and subscribe this channel, and if you have any comments, please write down into the comment box, and see you in the next video. Till then, goodbye.